All right. FMEA. Can I have volunteer? What is failure mode? Recap. Contoh. Failure mode. Contoh. Yes. Thank you. One more. Failure mode. Pump cyst. Okay. One more.
Vibration.
Vibration. Yes. Silly. Yes. You notice these keywords? These keywords is something that you can see, you can see, you can know, you can feel, you can hear. Okay, right. Failure mechanism? Reaction, yes. Due to something, corrosion, yes. What kind of factors is failure mechanism? There are 4 things.
Force, reaction, temperature,
temperature and time factor due to aging, right? So all these are 4 factors: chemical reaction, physical reactions, process related, or combination of that, which is the mechanism, failure mechanism. Okay, just to do a little bit of recap. All right, so hopefully that this term is no longer alien to you, right? Something familiar to you. Okay. Okay. FMEA is slightly, in short, is a simplified way. When you look at this morning, Mr. Sura has guided you on the RCM. FMEA is slightly simplified. Like what I mentioned to you just now, failure mode, failure mechanism will be there. One more thing. Later on you will find out, right? Okay. So why okay, let me see. Okay. In which a process or system to determine the effect of a cause. So this one will be something that you guys will work on this afternoon. What kind of effect, what kind of causes for that particular failure. Okay, to come up with some control plan. Control plan, action item, mitigation task money actually is the task list or the ITPM that you guys going to derive later on. Is it up to the task list is good enough in your FMEA? Is it good enough? What else is missing? Right? What else is missing? Beside FME, beside failure mode, failure mechanism, failure effect, failure causes, then you derive your ITPM. Is it good enough? Oh, good. Can submit already? Go to SAP team. SAP team, thank you very much. So later on, close shop. Thank you very much. Is it good enough? Okay. Recap. Failure mode. Failure mechanism, right? You mentioned already. Now we're going to understand more about effect and also failure causes. Okay. The severity, how severe is the causes, then we'll go to consequences. Okay. After that, the outcome from here, you will have something like an action plan, or people have many terms lah, right? Action plan, what you call that? Action item, apa lagi? ITPM, apa lagi? Task list, mitigation task, right? Is this good enough? What is missing? What is missing? What is missing here? You derive your do this checking, right? Do this monitoring. So you're asking the person to do it. Ask who? Ask who to do? Yes, the who and when? Not when. More specific? Yes, frequency. These two are missing. When you derive FMEA, nobody will tell you this. Usually people stop here. Then you submit this to SAP team. SAP asks you back, who to assign this? How frequent I need to do this? Starting when I need to do this? Okay, your FMEA process should complete the whole cycle, including who's supposed to do what, and then how frequent they need to do. Alright? This is actually to summarize. Summarized version. I go back to here again. Why we need to go back to here? Because inside this FMEA, should I start from here? From here? From here or from here? Which level I should start?
6.
Yes, we should start at level 6. Why level 6? Equipment level. Should I start at system of the plant? No, right? It's too high level. Okay, then 6 onwards we should start, but not at the component level. Okay. All right. So this one FMEA can be applied at various levels. So what I'm trying to tell you is it's a level 6. It's an equipment level, equipment class level. To identify the required action to reduce the risk. Okay, when people ask you why you need to do this, actually is to reduce certain risk. What kind of risk we are talking about? What risk? Risk of failure then lead to system downtime, okay, repair costs, okay, that kind of risk. To identify the maintenance operation design tasks that will have the significant impact to reducing the failures. Meaning to say, what kind of tasks you need maintenance to do it for you, what kind of tasks that operation need to do it for you, the kind of tasks that will be significantly to reduce your failure that you identify in your FMEA. Okay? Your deliverables will be a set of tasks. As I mentioned, it's a set of tasks. Okay? Recommendation, mitigation tasks. It's a set of tasks. The task can be, what kind of task? What kind of PPM? What kind of preventive plan? When you say task, what kind of task? Okay? Testing? Inspection. Testing. Overhaul? Overhaul? Cleaning, okay, cleaning. Replacement, toka, filter.
Collection.
Task. Task. What are the tasks actually you put in your SAP? What are the tasks that you usually routinely you asking people to do in the FMEA? Functional test, testing, inspection.
Can we put sampling?
Sampling, yes. Sampling, yes. Lot test, yes. Testing, yes. How about monitor the parameters? Monitoring, condition monitoring, checking the vibration reading, right? You're taking the data, monitoring, right? Okay. So this kind of task you will observe in your FMEA, the outcome of FMEA. Right. So this is kind of like guideline, right? Guideline that if you want to read more about FMEA, there are many actually others international guide that you can go through. Okay, this is some of them. When to use? First, you got your new equipment, use FMEA. If you got something that you want to apply on the existing equipment, you can also use FMEA, right? If there is already like the task is already bring like day one until now, you need to review, you can use FMEA. Is it all equipment you need to do FMEA once again? How we prioritize FMEA exercise? Yeah, we depend on criticality. Okay, not all, not all. Otherwise, you become FMEA engineer. Okay? All right. FMEA benefit will increase reliability, safety, right? Reduce environment impact, because some of the equipment is actually meant to measure the environment impact. For example, your analyzer, right? Improve process unit availability and reliability, increase maintenance efficiency. Okay, so all this actually is part of the benefits if you implement a structure FMEA way. When people tell you no need lah, do this only, do ABC only. Okay, but then you're asking, why need to do ABCD? Why not do X, Y, Z? So that kind of question you might occur, no? So during the sessions, actually you need to ask, like what Mr. Sora mentioned this morning, you need to ask the functional failure. What kind of failure modes? Okay, so that kind of question is a structured way to derive your ITPM. Is SCE task part of your ITPM or not? Yes? Yes, I mean SCE task is part of your ITPM. So if you derive your FMEA, of course you have to relook at whether that equipment is a SCE task or not. Kalau ada SCE task, then what happened? You ambil SCE task, then you add on the normal task that SCE didn't do. For example, you check on your loop oil level. SCE task do it or not? No, they don't do it. Compressor, they don't do it. Compressor, they only do certain things. For example, overspeed, they do it. But checking your loop oil level, you use PM. Right? Alright, so FMEA, you need to ask this kind of question. When you are facilitating the FMEA, you need to ask about the function, what kind of functions, how is it fail. When it's failed, it doesn't really matter, or I just change it, do not have any consequences, right? So there's kind of questions. How bad it is if this is already failed? Do I have another redundancy? So there's kind of questions. Okay, so normally people use failure, functional failure, failure mode, failure effect, failure mechanism, and failure causes, which already derived for you. Okay? Alright, something for you. What are the common failure causes? What are the common failure causes? Okay, 1, 2, 3, 3 groups. Give me 5 at least. 5 common failure causes. Okay, go to your group, discuss 5 common failure causes. 5 minutes. Get one person to answer. Get one person to answer. Failure causes.
so then I think that
Okay, tips and tricks. Tips. Failure causes is to answer the question of what? Why, what, when, how. Which one? Why is to answer the why. Okay? Yep.
FMEA is related to
ERS. Inside ERS. Here. Here.
So improper. So we will do our ECA first. Okay, and then from there we will derive our FMEA for the failure modes and mechanisms, is it?
Yep. From the ECA, you know the criticality. In a way, you know the function of the equipment, correct? In a way. From the function, you need to know the functional failure. For example, this pump supposed to deliver the liquid from this pressure to this pressure. What happened when this function failed? What is a failure? What is a failure mode? Unable to deliver certain things, right? So this is a failure mode. So where is the failure mechanism? So all this is coming in the FMEA. The function of the equipment itself.
But then this is done during the development of ERS.
Yes, yes.
It's not failure mode effect analysis.
Okay? 5. 1 from here. 1. Design? Okay. 1 from here. Misalignment. Misalignment
Cause vibration, failure mode.
So should I say operational error? Should I say operational error? Somebody have to do it, right?
Yeah.
Okay. How about this one?
Installation error.
Installation error. Few more? Human error. Operational error because the person who doing it, right? Some more? Some more? End of life. Is an error? For example, you're telling a person O is an error.
It's not, it's time.
Yeah.
It's time to go.
Okay? Generally, you can have this common. You guys got it right? Installation error, but this one you don't have lah. You guys don't do this fabrication. Design error, operating error, maintenance error, other work management error. Something like a planning lah. This one is so-called planning, right? Planning not at the right time. Okay. Anything not add on?
What is example of other work management error?
Planning. Something to do with planning. Wrong planning. For example, like you're supposed to do this job when there is a USD window, but you didn't plan it properly. You only do ABC. Then tertinggal pula D. Is your work management error. Then D, when you didn't do, another failure, hidden failure come out. Because you didn't do it, you forgot. Because your alignment of planning didn't do it properly. Okay? Anything else?
Can you please share this failure
causes?
human error.
Human error. Human error is more to the operating error lah. When you're operating the equipment itself. Human error, for example, like, okay lah, this one belum fail lagi. No need lah, skip. Right? Ataupun you do a control what functional failures, You just do partially only. You didn't do it fully. Something like operating, you on the way to operating it lah. All right. This is particularly important when you do your root cause analysis. Can you relate it? Can you relate it? Can you relate this to your root cause analysis? When you do your executive summary in your root cause report, root cause analysis report, at the end, people will ask you, what is the problem? What caused this to happen? So this is generally the common one, right? Kalau you baca ISO, you have more details. Let me show you. Maybe here. Failure causes. Oh, 187. Oh, sorry. Oh, this one. Okay. You have more details over here. Right, slightly different. Slightly different is more to grouping of the causes. So whenever you guys like doing the root cause analysis, you can have a refer to the common errors lah. Okay. Right here, others. Okay, other. All right. So I go back to here. You know how to find this document? I think somebody shared the ISO also in the chat. Yep. Okay. All right, let's continue. Okay. Just now I show you is a 14224, right? So it's all mentioned here also. Just now there's many guides, but some of them is not defined. You have to awareness. Okay, awareness. Some of them is not defined, but that's why we are referring to ISO 14224. All right. So just now I'm asking the question like what, when, how, why, how we actually map to this. Failure mode is the what that you see. What? Hear, see, smell. Okay, what? And then effect is something like what is or are the consequences? What happened if the failure happened? Immediate effect. Okay, and then the severity is like how is the impact level? Then you are defining in the consequences. This one is describe the how. Just now you guys has already put in some examples, right? This is the mechanism, the chemical one, the physical one, right? The time factor, the temperature factor is all here. Okay. Causes, why? Answer the reason why. Okay, why it happened. So this is generally the guide. You guys can refer back to here whenever you go through some FMEA exercise. Alright, so this is the terminology, the terms that explain to it, but it's the same thing like what we show you just now. Okay, contoh, examples. Centrifugal pump sees, somebody actually give the example, right? Pump sees, then will be mechanism is because it's stuck due to misalignment. Then it's stuck. Why it's stuck? Improper installation. Okay. Ataupun component design problem. Okay. Second examples, the pump sees because of many reasons as well. Okay. The pump sees can be due to the bearing damage due to excessive wear. Okay. And then this question will be excessive loading of the pump. So this is kind of like the failure causes that you guys seen just now also. Okay, by category. Any question? Question? No question. Okay. All right. Again, this is just the step lah. When you perform the ERS or FMEA, first you know your criticality first. Ask, is this critical enough to do FMEA or not? Or is just a C3 equipment? Okay. Define equipment information, boundary and functional. Okay. Failure modes. Mention? Mechanism, cost, probability or rating. Probability rating, what is it? What do you mean by probability rating? How? Yes, how frequent it fell. Okay, how frequent it fell. Why this one important? Why this one important? Huh? Why we need to know the how frequent it fell? Yes, there's one thing. Or maybe we should think of the way that why is it fell so frequent? Is it something like not as per the design? Right? Is it something like undersize, oversize? Okay. Then the effect, consequences rating. Consequences rating is some very similar like what you guys did yesterday. Safety, right? Productions. Okay. What else? Asset damage or reputation. The peer. Okay, to come in. Existing control meaning to say currently what you guys have been doing, okay, what kind of task has been doing, and then after you do this, what are the leftover, the risk, is it still acceptable or not? Why this question is acceptable, we need to ask, because if operation telling you that never mind lah, let it fail lah, I just replace lah, they will answer you like that. Okay, is it acceptable or not? You keep on replace, right? Apalah, fail saja lah, I just replace. Ataupun you want to rectify it, you need to ask, why is it fail so frequent? Okay. Then after that will be finally recommendation, which is your ITPM lah, your PM task. Simple enough? Simple enough? Any question? No question. All right. This is the complete spreadsheet. Okay, we can have more simplified. Okay, this is like so many things to key in, right? So many, right? You need to key in what kind of failure mode you see. You see, you saw, you hear, right? Mechanism is what causing this to happen. Failure causes, why? Answer the why. Then the number of types are livelihood, the effect, the consequences, what is the level of impact, okay, as well as the system controller, okay, and also finally is the recommendations. Okay, with the template, can develop the template. Okay. All right. Let's do one thing. Who is an electrical background? Yes. Can we do a very quick exercise together? Boleh? Failure mode. Motor overheat. Please derive mechanism. Electrical? Motor overheat sebab apa? Mechanism dia. Sorry? Bearing problem? Boleh? Ada lagi? Overload? Ada lagi? The pump rosak, then the motor?
Being overheat due to the pump.
Okay. Overload lah in a way lah. Okay. Okay. Two first. We keep it simple first. Effect. When the motor overheat, what will happen? Motor trip? Motor trip? Okay. When motor trip, what happened? Okay, causes first. LV motor, HV motor? Make it common first. LV. All right. When motor trip, the causes is?
For me, it's use cold gas after cooler, so it won't cool the gas. The protection.
Motor overheat. What is the causes? Why? Why the motor overheat? Overheat.
Dry, please.
Sorry? Yeah, it can be operating outside your limit. You can make the load. Okay, you overload or operating outside your envelope. Operating outside. Okay, SOL. Failure consequences. Okay, if pump cannot run. Kalau overheat, you terus trip kan? Kalau motor trip macam mana? So your system downtime lah. Okay, system downtime. Any safety factor tak? Safety? Kalau overheat. Any safety factor? Safety risk? Yes, motor rosak. This is like asset damage lah. Okay, asset damage. Right. Simple like this. Can get the relationship. Okay, so any more things I forgot to cover? Do you need any cooler for the motor actually? Sometimes? Okay. What happens if motor overheat, the cooler also rosak? The cooler rosak, then motor overheat. It can be one of them also lah. Here. Okay. It can be many reasons. That's why in your FMEA, you have many lines lah. You have many lines, then derive the different failure mode or different mechanism. Okay.
It's same as hero.
Something like that. Yes. Similar. Yes. Similar. Question? 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 No question? Let me see what else I miss. Anything I miss or not? Okay, later on. Say this one. All right. Like just now, I think Mr. Sura also mentioned something like this. You need to define your scope, no? Your equipment boundary before you do your ERS. Then you need to set up a team. Okay? That related to your team will be something related to the boundary that you select lah. For example, like you select UPS, then you don't call in your mechanical to come in. Maybe they cannot give you the best answer for your question, right? So you have to select your own team, then go through all this failure function. What is the function of that? Then failure mode management mechanism until all the way to consequences. After that, you will have your mitigation task. Interval means is your frequency. Work center means is your who supposed to do it. Then integrate the recommendations. If there is a failure data analysis maksud there, you have your failure data, you have your probability already. You have your base like, this one in the past that used to fail how many times? Okay, last replacement was done when? Okay. Macam lemang aja. Okay or not?
Yeah.
All right. Okay, so now is 3 o'clock. I intend to give you some exercise. Okay, you can choose You can choose. Choose. We have 4 teams. Maybe one team will repeat one time lah. 2 teams will having same topic. Okay, choose whichever comes first. We have 4 teams, right? Team 1? No. Go back to the team like here. The ECA team. Team 1 is here, right? Okay, team 1 is rotating. Okay. Then detector siapa nak? Detector. Okay. Then UPS. Team 2 or team 3? Team 3. Team 2?
I don't know. I forgot team 2 is team 2. Pressure you right? You guys team 2 right?
No, follow your ECA. Follow your ECA team. Follow this 1, 2, 3, 4, right? This one. Team 2, select which one? Team 3. Which one you select? Rotating. Team 4? Ni. Again. Team 4, sorry? 1. So we have how many rotating already? Rotating and rotating. Detectors and UPS. Correct? Alright. So this is your case. For example, I will give you component inside the pump. This is a functional failure. You only work on this. Don't work on the whole pump lah. Okay, we don't have that. I just want you to get the concept first, right? So that's why I give you this functional failure. Fail to transfer the liquid at the correct pressure and flow to meet the requirements. So the failure mode is high vibration. Second, seal system. Fail to maintain the leak lah. Okay, leak tight integrity. So mechanical seal leak. You guys also mentioned that in the failure modes. So this is the tagging. Since this is the operating parameters, okay, and then a component into it. So this is the equipment boundary. Alright. Next. Detectors. You have 2 component here, sensor and electronic component, unable to detect abnormal temperature. Failure mode is fail indication. Signal. Spirit strip lah. Okay, unable to receive input, and then there is a failure mode will be no output. This is your equipment boundary. This is your equipment description as well as your component inside your boundary. You will need this during your FMEA. You need this to collect the data first. Okay. Last, UPS. No main supply, which is your UPS and also the battery. So fail to provide power for battery bank, cable short circuit, fail to provide backup power, breaker faulty. This is your UPS and also your component, your equipment boundary. 3 groups. Alright? How long you need this exercise? 30 minutes? Alright? So 30 minutes, after that we go for break. Okay, stick on the wall for your, put it into the landscape mode, so that you can, your template will be something look like this, Something look like this. Component, function, failure mode, mechanism, cause, effect, consequences. Then will be medication. Siapa yang buat? How frequent you do it? Any remarks or not?
Both of the components are.
Yes. Already mentioned here, right? Just now we already mentioned here. Consequences, mitigation, and work center. Okay. Sorry, another one is your functional, because just now I give you already functional failures. So you just copy only. So we include all things here lah. Who and how frequent. All right. Oh no, just these two. To get the concept, you don't have time actually.
Just the pump,
Yes, the pump. Yes. The pump, the component, the functional failure, and also the system. Let me do like this.
This one is I'm not sure. He said
Functional failure already, you just copy. Failure, what you just copy. What you need to derive is your 1, 2, 3, 4, 5, 6, 7.
component function. Which one? Which we do it on the paper or?
Yeah, on the paper. Please do it on the paper. On the paper. Satu paper tak cukup, dua paper. Okay. I'll enlarge for you guys. Which one?
The first one first.
The first one first. First one first. Then detector. Sorry. Sorry. Detector. Okay. UBS okay already. Okay.
Apa yang
So
Kalau disalah dimasukkan
better stick on the wall first, then you guys can easy to write it on.
Michelle,
Yep.
can I put when required under my list?
Better not.
Better
Not recommended. Unless you are replace the things lah. Replace the seal, right?
so where required.
Condition based lah, you are saying, is it?
So, or I put to replace seal when required. And this one I put.
Yeah, but when SAP team look at this, they don't know what to do.
Betul. So how in this case?
What you can do is, in your task list, you just to list there to replace if required. In the task list itself, tapi tak ada the particular task itself lah. Tapi it's inside the long text.
Tapi dekat kita punya FMEA ada task list. FMEA ada task list.
Yang ini ada task list ya? Medication tu is the task list. They will convert it as a task list by your frequency. Tapi for seal system, you just need to monitor. You just ensure that the lubrication is okay. If your lubrication out, then your seal also out lah. Because your seal is like what you call that? Your seal face is already like going together with other components. So you have to ensure your lubrication is okay actually.
So in cases like this one I leave empty lah kan?
You can just put when required, or you just mention something that you get ready the sparing lah for your seal. Definitely, if they got leak, they will replace actually. Just that how to prevent this from happen. Seal will not last forever, right? And at the end of the day, you will still fail. Just that how you prevent it.
When leak.
Yeah lah, when leak. Tapi what is the thing to protect the seal? Is there anything to protect the seal or not? Ensure your fluid coming in actually is operating, dia punya parameter is okay, temperature macam mana, pressure macam mana, dia punya medium macam mana. Okay, maybe we can start already. Okay. Okay. All right. Yes, we can start already.
You can put it, but it's like
What time you guys want to go back? Now also can? Yeah? What time you guys want to go back? Okay. Jum. Okay. Which group want to start first? Which group want to start first? Select your presenter. Then everybody at one discussion. Which group want to start first? Which group want to start first?
They're ready.
Okay, they are ready. Okay, everybody focus here. Come closer to help your friend. Challenge them. Challenge. Ask questions. Imagine this one is your sessions. You just allow this. Okay, is your friend doing the FMEA? This is the case of the pump, right? Come in and challenge them. One discussion, please.
So good afternoon, everyone. Our component is pump. Okay, so the function of this pump is to transfer liquid at correct pressure and flow. This one, it should be more specific if we know the pump spec, but we don't know, so you just say that. If you do it
One discussion, last discussion. Everybody,
in real time,
please.
put in the operating conditions, whatever. But for this case, we don't plan.
Assume.
Yeah. Alright. So failure mode is high vibration, failure mechanism bearing cyst, failure cause under greasing. Kat sini kita lupa nak letak failure effect. So failure effect kita kat sini. Failure effect unable to transfer liquid and pump trip. Okay. And then failure consequences, asset damage, downtime, until downtime. Our mitigation is to perform greasing 6 monthly by area maintenance. Maintenance lah. Area maintenance, mechanical.
AIM.
This one is like our code.
Oh, okay. Okay.
Okay, our reference is the OEM operation manual lah. Okay, so anything you want to add, you want to ask?
Yeah.
Kalau macam yang under greasing tu operation error lah kan maksudnya. Operating error.
Siapa yang grease? Operations ke maintenance?
Oh, maintenance error. That's a question for discussion.
Maintenance lah.
So dia ada maintenance error lah kan.
Yeah.
Okay, anything else?
Consequences tak ada production.
Okay, so downtime ni, we put downtime lah. I think downtime your LPO is ni lah. I think lah. Oh, should we put LPO also?
Yes. Why there's a LPO? You consider what? What is in your consideration?
Kalau LPO, no standby. But
LPO means is what?
production.
Why there's a production loss?
This pump.
Did you mention anywhere your pump will trip?
Yes.
Yes, okay. When the pump trip consequences is LPO, asset damage, your pump will rosak lah in a way, right? Okay. So you mentioned something like your system failure, your system downtime, your pump downtime will trigger the production loss. Let's just say you don't have redundancy.
So that one is under consequence.
It depends on what is the function of your pump. Pump from what to what. Kalau your pump fail, is your whole system fail or not?
So let's say if it doesn't have any standby, doesn't have any
Yep.
anything,
Yes.
then it will fail.
Yeah, it go to the function of that pump. What is it supporting? Pump what? Right? Is the pump fail? Is your system fail or not? Is your system fail? What happened? Consequences there. Macam tu. Okay.
We consider the equipment boundary as well, right?
Yes, exactly.
In our case, if we only consider the pump.
The pump, but the function of the pump. Yep. Pump what? Okay. Right. Any other question for anything? Questions for vibration? Vibration. The what you call that? Bearing cyst. Oh, okay. Kalau bearing cyst ni, what will be the causes? Biasanya? Sorry? What else? Kalau bearing cyst? Okay.
Incorrect grip of risk.
Okay. How about installation? Okay. There could be another one, you know. There could be another line. Okay. So what you're going to do with the how variation? Mitigation there, perform grazing. Okay. 6 months. The frequency depends on what? MDPF. Kalau dia tak NTPF? OEM. 6 months, is it fixed? Forever you run 6 months? No. When you need to review back this again?
Yes,
MSR.
MSR or there is a when yes, yeah, when there is a failure, then you review this again. Whether you need to do it like 3 months, can. All right. Second component.
Second component is the seal system. The function is to prevent leak and contain the liquid within the pump casing. Our failure mode here is mechanical seal leak. So the failure mechanism, once again, is seal sys.
Seal sys.
Okay. Seal sys. Alright?
Seal sys. Okay.
Okay. Yeah. Failure cause incorrect installation. And then it goes to failure effect, liquid leak into surrounding. Failure consequences such as damage and then downtime lah here. For both of these is the same. Mitigation to perform visual inspection and monitoring of leakage rate, temperature, itulah level and all stuff lah. Per shift by operations. Yeah. Itu satu. And then the next one, this one is a bit open for discussion. This one is to replace seal when required. So when we put when required here, our problem later if we want to translate to implant, right? Susah we wanna put into it jadi implant. Yeah.
Question. Any question? Seal sys? What will usually happen now when, what causing this mechanical seal leak lah? Usually what happen? When you open up the seal, what you see on the surface on the seal?
This one is for dry or wet?
This is a crude lah.
Sometimes if you see the mechanical seal,
The seal?
you can see the containment of the what the pump is pumping. It gets to the other side lah. It's either the pump casing or if it's single shaft, then it gets to the motor lah.
When you open up the seal, the seal surface, what you usually see? Okay, rubbing. What causing the rubbing? Debris, yes.
Misalignment.
Yes. Correct. So that was the immediate. Okay. Misalignment, installation error, something foreign object come masuk already. You rubbing it. Okay.
I want to ask if the clinical start installation of seal and then let's say alignment problem.
Yep.
So maybe it depends on the pump also, right?
Yeah.
Don't have any spares. But if have any spare, we just can to do the realignment back, right?
Yes, exactly. Yeah. But you have to ensure the alignment punya 5-point check. Bila nak do alignment usually?
Usually we take the vibration first lah.
Yeah. Then how frequent we monitor the vibration?
Within 3 months.
Yeah. The vibration mana? Monitoring vibration? Yeah, your monitoring vibration mana? Mitigation dia. CBM. Oh, okay.
3 monthly CMG.
Oh, okay. Right. It's not inside your high vibration punya ni
No.
Okay.
Why we don't put here?
Satu line.
You can also monitor lah your vibration monitoring. Okay. Anything else? You observe? Okay. Anything else?
Question.
Bagus
For
lah
the
ini,
mitigation.
komprehensif lah.
So do we address the failure mode or the failure mechanism, or we address?
Failure mode, failure mechanism. Usually they have to combine together. Especially, you have to look at overall pictures. It's not like addressing which one, but mostly because failure mode is what you see, but you don't know what happened.
So we have to address.
You have to address as well. Yep. The fine point check, the how usually your manpower, who doing that. But in order for you to put into the task list, this is which one is a task list actually? The mitigation, yes. So you need to have a task list as well as who's supposed to do the job lah. And then how frequent?
Just now we said that to replace seal when required for it to be unplanned, right? So can we add that to perform usual inspection and then and replace if required?
Yes, inside your task list. But in your SAP, you don't have an individual line because of replace It's inside your task list. Yeah, inside your description. So I'm telling you that actually you want to replace a seal, then you have to get your sparing in. So inside your FMEA, you have to mention the remarks, how much sparing that you need for the seal. Kalau nak replace seal, how much sparing you need? But what are the things to protect the seal actually? Anything to protect the seal?
Depends on what kind of seal. There's also protection system.
Okay. This is not dry seal, dry gas seal. Alright, can we give a round of applause for your friends here? Second group. Siapa? Second group. Any volunteer? Presenter? Please. Okay, please, one discussion. Okay, this is about UPS, whereby you have a main AC supply and also a battery unit, right? Okay.
So, good afternoon everyone. So, our team is doing for the UPS. So, for your information, UPS stands for uninterrupted power supply. So, when there's a blackout, basically only the UPS will function. So, all the emergency ratchet, the ENMC will work based on the UPS and it's one of the most important device in electrical system. So, in the UPS, we'll take two sample of failure. The first one will be the main AC supply. Second one, the battery unit. So moving into the first one, main AC supply. So the function of the main AC supply is to provide power to charge the battery. So this main AC supply is also to provide power in the normal condition, and the battery will only support the supplying the power during the power failure, which is during the blackout. So the failure mode of the AC supply would be due to cable short circuit, so which is the underground cable that we cannot see at all. So the failure mechanism probably due to the cable insulation degrade. So the insulation normally is a very high resistance thing. So during the failure, it will drop to maybe lower than 5 mega ohm. So the electricity can go through the grounding, causing the cable to short circuit And what can cause the insulation to go down to below 5 mega ohm? Probably due to the moisture, the water ingress into the cable, causing like 1 to 3 electrical spark and eventually causing the short circuit. And maybe the temperature, the cable has over temperature for a prolonged period and causing the insulation to degrade over time. And the acidity, because the cable is is underground, so there is acidity in the soil causing the degradation again, or the design failure, which is the specification of the cable simply doesn't meet the requirement of the usage And the failure cause, what can cause? This one. Failure effect. So what happens when the main AC supply fails? So basically, when main AC supply fails, means all the plant is blackout and only the battery is supplying the power. So yeah, so we will be having blackout and also fail to charge the battery lah. And not necessarily blackout, just the power line of the UPS that line would be having blackout, and it will also fail to charge the battery. And when the battery fail to be charged, the battery will decharge, and yeah, there are risks of no power supply during the blackout of the power line of the particular main AC supply lah. So what can we do to prevent the failure? So basically, we can perform the condition-based monitoring on the cable. So the cable, because it's underground, and theoretically, cable is a very, very stable device. So we will only perform condition-based monitoring after usage of 20 years, and yeah, starting from 20 years, we will only perform the CBM every 3 TA. So every 7 to 10 years we will perform once the CBM on the cable. So basically, we want to get the insulation, the resistance of the cable, as well as a lot of technical thing on the cable lah. Yeah, so the work center is electrical. The reference for the condition-based monitoring is the mean time between failure. And yeah, trust us, we are the engineers. Okay, so this is for the first failure.
Yeah, any question?
Good.
Okay, and for the second one, the battery unit.
For the cable, do you have any like connectivity test?
Yeah, we test the connectivity on the cables, but since the UPS it supply power during the blackout, so it is the SCE lah, so we can only down it during the TA, so we will do everything.
Oh, no redundancy, only TA.
Yeah, only TA. Yeah, actually we have redundancy, but we have to do a lot of switching to achieve the redundancy. Okay.
Okay. Any more questions?
For the perform CBM cable,
Yeah.
is it okay like this if we just put CBM? We don't need to specify.
Yeah. The technical terms we don't need to specify.
We will ask, is there anything else you can do as a routine? Inspections, testing that you can do for the cable? Is it underground? I mean, it's like hidden?
Yeah, hidden.
Okay.
Underground. Totally we cannot see it.
Okay. But for us, we can see. We can see.
We can see.
We can see the cables. Yeah.
You mean?
The UPT itself is like the cabling. We can
the
see.
cable is short, but the actual cable is.
Yeah, we can outside we can see actually.
Yeah. Okay.
The connectivity we can see.
Right.
Yes. In that case, we can do the inspection.
Yeah, the visual inspection.
That one could be the task lah. You do the visual inspection. Is there any like dirt or loose connections, vibration around the area?
Yeah, sure, that one can be done. Okay.
Okay.
Next.
Okay, next the battery unit. Since we mentioned during when this main AC supply fails, the battery will be supplying the power. But now the case is, the battery unit function is to provide backup power during the blackout. And the failure mode we're considering now is the circuit breaker for the battery is faulty. So basically the battery is healthy, but the circuit breaker is faulty. So the failure mechanism, when the circuit breaker is faulty, so circuit breaker basically during the overcurrent or something short to ground, from battery to ground, it will trip lah. So during normal condition, the circuit breaker should be closed, but during the forced condition, it will open. But now when the circuit breaker is faulty, it will forcibly trip. So what can cause the circuit breaker to forcibly trip? Maybe due to aging or design factor. Maybe the circuit breaker the specification is wrong, like the overcurrent rating is set falsely. Yeah, design failure. And the failure effect is, when the battery circuit breaker open, so means it cannot provide power during blackout. So basically, for example, if the UPS is for the NMC, NMC stands for if you ever go to the panel room, you will see a lot of panel. So basically all the power of the panel is supplied by the UPS lah. So that during the total blackout, we can still see everything on the panel. So we can still monitor all the process. So the consequence of the battery circuit breaker to fail, which is, probably there are no power supplying to the ENMC, so we cannot control all the process. And if there's a very important, very serious case, because the operation cannot monitor, maybe some is having a high pressure and they cannot access to the panel, and it might cause a explosion or anything lah. But the most not serious one is the no power during blackout only lah. And the frequency to perform mitigation, sorry. We have to perform PPM for the circuit breaker lah, which basically is still during every TA lah, because we can only switch on and off the circuit breaker during the TA and work center, electrical, and TBA.
Any question? Question?
I have a question, but it's for you. So for failure cost, temperature, acidity, that one, moisture is all environmental factors. So I get it. Kalau saya pun saya group it together. But the last one is design. Can we do that?
Design, actually, you have some evidences lah. Whether or not it's really due to the design. Usually, failure causes we don't put design lah. Unless it's new, because you're already operating so long, then tiba-tiba you say it's a design failure. So it macam not that logic lah. Okay, so all right. I think I observed that you put tasks like going to every TA. So how about the normal things you do? Meaning to say you have your UPS there, you have your battery there, you just PM macam tu saja. Then only TA I come and look at you, no right? No. So the normal one, the normal PM macam mana? How you do it?
The video
right?
inspection, we just open the door and see if everything is okay, is everything running.
And also how you ensure that the UPS is charging to the battery. Then how frequent you need to do that?
Every weekly, the EBC.
Weekly.
Make sure that UPS is charging to the battery. That one I didn't see here lah.
Okay.
How you ensure that your main AC supply is okay, right? Yep. In fact, no, that one is checking your, doing the test. Charging test, decharging test. That one could be your maintenance. So what I'm trying to tell you is this concept is not that the task is master TA, you only then go and see it. This one for me is like, you don't need to do anything. Master TA, you go and see it. That's all. No, right? We are not doing that, right? Okay? We still have some normal PPM, to check whether our UPS is okay or not. Right.
But bukan kita macam jatuh under existing safeguard.
Existing safeguard. Okay. Yeah. Correct. You're right. Meaning to say, what are the tasks? Imagine that the existing task is which one lah? Currently we don't have lah existing task. Question?
For the consequence, I think there's no like really effect on the production PAR. That one is unsafe shutdown lah kan?
Not necessary shutdown, but we simply can
actual blackout. So the plant should shut down lah.
It depends on how severe is the blackout lah. If only that UPS supplying the
UPS supply, so actual blackout,
the total
so no
blackout.
battery, so unsafe shutdown.
Unsafe shutdown, right?
Because UPS is a SCE, so how UPS come into SCE actually?
For shutdown.
For what actually?
For the critical equipment.
Yes, the vital load, correct?
Vital load.
Yes. So in that case, you're unable to supply to your vital load lah. Vital load, no power.
So this FMEA function is for us to determine the mitigation and also the frequency, right?
Yep.
So how does the failure consequences plays a role in that? Because the more catastrophic we
Yes,
the same
correct.
mitigation and frequency.
Macam sama kan? Yes, you are right. Because this one is a SCE. They have a SCE task actually. Even though SCE task, as I mentioned to you, you still need to do the charging discharging test, which I didn't see here lah. So that one is to ensure that your UPS, your battery is still in healthy mode.
Oh, because healthy is okay. Not inside our scope lah.
Oh, okay. All right.
Can they have kalau backup?
UPS tadi.
UPS.
Provide power when there is blackout.
How to GTG?
GTG to the ratcheting machine or NMC depends on what the load is connected lah.
Vital.
Yeah, vital
Vital
load.
load.
Or far the instrument DCS panel. Yeah, but
Banyak.
depends.没有，那是battery 很坏，坏掉 battery，battery 没坏。
But first thing, your circuit breaker actually terbuka, right? Terbuka. First thing first, what will you check?
Check why it buka lah.
Yes.
Yeah, find all the previous history. What's the current?
Correct. Yes, it could be overcurrent, right?
Real.
It could be real trip. So the failure causes could be
This one is the failure mode is the CB40, right?
CB40.
How does your battery discharge test have to do with this?
Explain.
Oh, actually, battery discharge is only when battery is failing, which is a little bit outside our scope.
Okay. Okay. All right. Thank you. All right, next.
Desmond siapa tu?
Desmond go.
Oh, ya Desmond go.
Let's go. Good jam pagi, orang kata tadi.
Desmond go.
Are you sure?
Sure. We need to be confident.
Oh.
Okay. So our component, we have two. One is sensor, one is active component. So the function of the sensor is to detect it actually. Okay. Next, okay. The failure mode will be false indication or intermittent signal. So the failure mechanism will be the sensor unable to detect the temperature change actually. Then the failure cause will be open circuit of the sensor or aging sensor. So anything can be aging, alright, especially in sensor. So all the time the sensor is directly to the heat or the process medium So it will tend to become aging Okay. So the failure cause will be open circuit of the sensor. Next. The failure effect will be fail to trip on demand, and the failure consequences will be asset damage, production loss. It could be fatality or reputation damage. The mitigations is to replace the sensor, or with testing or do inspections of the sensor when we have any window opportunity And the frequency will be followed by TA or recommendation by DOS or center instrument. Reference will be NTBF.
Slow me kan.
Because that two info baru tambah. Okay, any question? Okay, next.
Okay, sensor. Mitigation macam mana?
Question, kalau tadi kan kita kata tadi kan misal kabel tu kita tengok, kita test semua tu. Tapi kalau yang macam ni,
sensor macam mana nak test?
kita nak tahu.
Yes, sensor.
Okay, again. For your question, I'm sorry, your questions?
I change question lah. Okay, macam mana kita nak differentiate sensor tu rosak ke tak rosak ke? Kalau dia kata kat sini follow TA kan, atau recommendation by Dodge. Tapi kalau contoh Dodge lagi 6 tahun,
That's why I said here just now. So the frequency, so for the mitigations, it's either we request the sensor when it is faulty, or we do testing or inspection when we have the opportunity window. Kau instrument kan kau tahu kan?
You guys do not have any testing when the thing online?
Cannot.
This one is gas turbine, so everything is inside the
compartment.
When the gas turbine is on 8K, you don't do it?
What is 8K?
Kalau yang breakdown kita buat lah.
Okay.
Kalau dia down memang kita, that's why I said.
TTT.
8K you mean 8,000?
8,000 running hours.
So frequency when there is any opportunity lah.
Kau sama ke aku kan? Again.
Frequency when there is any opportunity lah.
Ya betul. Contohnya kita ada trip ke ada apa ke, kita akan loop check lah. Usually there will be a system to loop check the whole thing lah. In MLG we call it as minimax lah.
I see.
So when it is error, it will tell us the alarm already is there. There's something wrong with this transmitter, so we will replace it when there's another opportunity lah.
That one is a smart type, right?
Yeah, smart type.
You got the diagnostics inside. Okay.
So just now, I just got the info lah. Okay. Tadi saya cakap apa? Sensor untuk pakai dalam gas turbine.
Betul.
So okay, kita tanya di online, kita tak dapat tengok yang sensor ni elok ke tak. Tapi what if because this one is heat sensor, so from the operator yang buat day-to-day operation, they can feel the something like heat ke?
Usually kan this heat
that is emitted from the gas turbine.
Okay, usually in gas turbine lah. I'm talking about MLG kan. Our gas turbine we have an enclosure, so we cannot feel any heat actually from outside. We have an enclosure to close the gas turbine, so the heat detector will be installed inside the compartment lah. We call it gas turbine compartment. Inside
enclosure.
Inside enclosure lah. Maybe you come to MLG, I bring you CC.
So you don't so usually what IPF say about this kalau the sensor inside the enclosure?
Usually what we can do is waiting for opportunity lah, because they have their own voting system lah. Like 2 out of 4. Once 2 out of 4, if it's really hit, you start to trip lah.
Okay.
Sorry, question. The failure mechanism.
Yeah, failure mechanism mana tu? Ini.
Yes.
Okay.
So your failure mode says that it's false indication, but then your failure mechanism says that sensor unable to detect temperature change. I thought failure mechanism would be something like maybe cable melt or circuit melt or macam sensor unable to detect temperature change is more like the failure cause failure mode.
So for the sensor, right, you detect the heat, right. For if it's broken, it can't detect the heat, so it can't send out any signal. So it could be false indication, and it could be also intermittent signal. Sometimes it's good, sometimes it's bad. Yes, unable to detect.
Mechanism is what causing this fail indication lah. What is
It could be the sensor lah. It is not able to detect the temperature lah. Alistair, I heard Alistair can answer.
So what is a proper any other mechanism for false indication?
No.
Maybe 40?
Actually, how we came up with this, right? Because we understand that failure mode is basically what we can observe. And then so failure mechanism is what led to the observation. And then that is basically what led to the observation.
Do we have a time factor here? Time, temperature, reaction, force factor here to derive the mechanism?
External, right? Because
the heat from outside, the aging factor.
Aging. I think because if heat, that's what it's supposed to do, heat detector.
Yeah, but exposed too long, then
Expose long start to air out lah. Macam kita dah tua kan, jalan pun tak laju, macam tu lah, so slow. For example.
Because this one is inside the enclosure, so you don't have any like ingress.
Water ingress.
No water ingress.
Usually
Okay.
Due to always exposure to the high temperature lah. Ingress turbine compartment is always hot inside there lah. So it always exposed to the high temp. It's not considered high temp. They have their tripping point. Is beyond the normal working temperature lah. So that's why it tends to start degraded.
I think we should start.
Yeah, it could be. It could be due to the time. Yes.
Okay, next. Next, I will.
Failure cause you said that aging sensor.
Betul.
So this aging sensor will cause dia tak dapat nak detect the change and so on lah. So kita punya mitigation adalah to replace the sensor and perform testing and inspection.
Or perform.
Bila interval dia adalah follow TA and recommendation method. Tapi you punya sensor boleh tahan berapa lama?
Based on my record, 20 years still working fine.
Kau kerja semua? 20 years?
Tapi usually kan maybe 5 years is still working fine lah.
Okay, so you nak tukar bila?
Usually every TA kita akan tukar heat detector, UV detector barang lah.
Okay, so TAU dalam 6 years.
3 years.
3 years. 3 years. So you have extra 3 years walaupun you punya aging sensor tu dapat tahan 25 years.
Yeah. It's better we replace than any accident happen lah.
Yeah, cheaper.
So you can see that they are going for what kind of strategy? Time based. How many maintenance strategy you have? Time based, risk based, or condition based? You only got 3. So they prefer to go for time based because in case of any failure to this is huge. Yes. During the session itself, you need to ask like what he asked you the questions lah.
Just recently, saya pun baru tukar heat detector.
So you pass or fail, you also tukar. This is your. Oh, okay.
Usually all semua masih bagus, we tukar.
Oh.
Emergency kaya.
And then usually inside the enclosure is belong to the rotating, let's say the gas turbine, right? So who is jaga the detector?
Still instrument.
Still instrument.
Inside the enclosure, still instrument.
Okay. It's not a rotating then sub instrument, no? Okay.
just in the real case, if that happen, it reach alarm, then what should we do? Bypass or?
No.
Tak ada alarm.
Dia trip terus. Trip terus.
Yep.
So if you have fire inside the compartment, for sure the temperature will rise up, right? So there's the heat.
One of the sensor dia sensor lain juga untuk detect fire.
Dia ada UV, dia ada heat. So dia macam dia ada voting system dia lah. Okay, next I pass the floor to Alistair. Please.
Thank you.
Component is electronic component. The function is to display reading. Again, because we receive input from our sensor, and then our electronic component will convert it to output and send to our RSS. So for the failure mode, no output. Failure mechanism, so what basically lead to this no output is the electronic aging. Failure cause is long exposure to heat / water ingress. Because electronic components basically is outside of the compartment, so they get exposed to, maybe if you don't have any shade, so you get exposed to it. So failure effect, fail to trip on demand, and as well as spurious trip. For the failure consequence, basically the same for the sensor, asset damage, production loss, could be HRDC and reputation damage. mitigation again, same as our sensor, replace electronic component, and then the frequency is run to fail. Center, the one is INS, and reference is MTBF.
Okay, question?
Michelle, this question is for you lah. Because if you see our group, for the reference we put the document, and for the other two group they are putting the MTBF. So is there any format or standard for the reference? What are the things that we need to put?
Reference usually is your guide or very close to you. Actually, the better is MTBF lah. If you want to put, yeah, because if you got the data,
So this one,
if you got,
reference should be MTTF, right?
yes, because it cannot be repaired. Yeah, MTTF because it cannot be repaired. If you don't have, just to answer your question, if you don't have any reference, please refer to OEM. Kalau you ada reference, for example that the upstream, then you go for your guideline. Actually, references you can more than one. It's not necessarily only one. Usually we refer to like upstream guides, MTBF, apa lagi? OEM, yes, SCE.
Sorry, mungkin Pak Dan tadi dah tanya cuba contoh electric components tu, tapi pada consequences dia kat sini, contoh dia fatality tu tak ada,
yes,
tak ada production loss,
yes,
but dia punya frequency dengan mitigation dia still sama.
Correct. Good observation.
In case
So you punya failure consequences is what? Asset damage.
For this time the same lah, tapi contoh kalau saya tukar, dia tak ada fatality, tak ada apa, but dia punya mitigation dengan kita punya frequency tu I think still the same kan, walaupun dia ada fatality.
No, I mean I think your point is even though you have a very big consequences, you punya task pun sama kan? Yes, correct. I think this is like what you usually happen inside the FMEA. Even though your consequences is so big, but you cannot do much about it. You cannot do much about it unless you want to invest in such a way that you punya electric component is very high integrity. You want to invest that or not? Maybe you have very high integrity lah. You come to things like that because detector is another SCE. That's why I give you guys is the Chonto one is very critical. Usually you jump it at your FMEA. So criticality like this, you look at the task. Actually, they do the normal things only. The normal thing, the basic care actually is part of your task list lah. It's not like very, how to call that? It's like many things you need to do just to address your consequences. Bukan macam itu. Okay. But I have questions like, for example, because this group is focus a lot of replacement. Fail tukar. How about your routine? How about your routine inspection? Right? What you're going to do with your electrical component, that kind of things.
So basically, is what Desmond told us earlier. We have what we call the minimized system. So we do have our PPM.
Yeah.
In a way, our technicians and as well as engineers we go for routine checking on alarms and stuff.
Yeah.
So that they can put it remarks into the check sheet and then.
Correct. There's some more, right? There should be some more here. The electrical component. Not only after 2 years. Fail you tukar lah. Electronic component. What else you need to do that?
I think electronic component we can't do much actually. Because it's small and it's not worth for you to change a small part. So change the whole thing is cheaper compared to changing the small electronic parts.
And then one more thing is this one is quite tricky because it's a hidden failure. You won't know. You only come to know it when it's already failed. So it's an instrumentation, a lot of hidden failure.
That's what we did.
Okay, so normal inspections, you guys still do, right? Like EBC, checking, everything, inspection. Testing tak ada lah kan? Okay. So that kind of questions, if you're coming from another discipline, you you must ask lah. You cannot treat it as a reliability, know everything. In nature, they have to cover for multidisciplinary, but the who is the SME is who? The discipline itself. Okay? Alright, any more questions?
Thank you.
Question?
I think it's okay. You guys very good job.
Yes. Satu last.
Apa dia?
Dekat sini kita cakap dia electronic aging. So you punya komponen elektronik tu dah lama lah.
Betul.
This human ACE kan?
Yes.
ACE. Okay. Kalau ACE selalunya kita orang tak bagi dia run to fail.
Betul. That's why I change every day.
They run to fail.
Itu just for the electronic component.
Okay. So that electronic component boleh aging. Certain time dia akan aging and akan rosak lah. Betul. Keluar display and so on. Tapi bila dia tak keluar display and so on, you punya consequences adalah asset damage, production loss, fatality and reputation. Kan? Tapi you guys punya frequency adalah run to fail. So you bagi the consequences tu jadilah.
Betul. Bagi at least tu jawab.
Sebab you bagi you punya frequency to replace that electronic component adalah run to fail. So bila dia fail, consequences tu akan kena jadi.
Kena jadi juga.
I think I try to answer lah. Usually kan, in instrumentation design, we usually have redundancy. So once this electronic component fail, it's only one of the heat detector as one function. We still have another function, and we also have our voting system, right? So it will not trip lah actually lah.
I think the consequences only happen kalau kalau benda tu ada api betul-betul. But the run to fail is bila dia fail, no output, kita tukar.
We know that there's no output, tapi
kita tukar. Jadi masa tu belum terjadi lagi. Consequences tu in case of kalau benda tu terbakar betul-betul.
When you want it to work, but it does not work like actually lah.
But yeah, I think how you know there's no output?
We can check the system.
There's no output.
So how frequent you check the?
Kalau ada no output, dia
Okay. So that one is consider routine lah kan? Okay. But this one is outside the enclosure, right? Or usually the electric component outside the enclosure, right? It's not in the DCS.
No. Dia pergi ke masuk mini-max lah. Card kita lah. Kat kita.
The card usually located at? But by the time you look at it, it's not blinking, right? You need to say no output lah. But how frequent you check it?
Berapa ppm kita bila?
6 months. 6 months.
So you have to go there and check got output, no output, right?
Usually our DCS, like if there is any alarm or you link to our DCS, you will have pop-up.
I see. Okay. Understood.
Keep flashing up the alarm.
You no need to go to physical see whether got light or not lah. No need.
Once our DCS will detect, then we know what to do.
Okay. You guys know how to ask a question in the FMEA later on? Imagine you are not from the discipline. Okay. Hey, one discussion.
According to the explanation just now, there is another unit standby, right? So if one fails, another one fails. So the consequences only happen after double jeopardy. Both fail, right?
Kalau dia fail, dia kira sebagai voting lah, dia one of something. So bila if something like satu tu detect, dia terus 2 out of 2. Yang satu tu dia terus voting bagi vote. Dia macam
you can explain.
Kalau satu rosak kan, dia jadi 2 out of 3. So still takkan jadi ya ini sebab takkan unless protection tu ada. So consequences tu betul. So bila jadi fatality meletup.
Kalau semua rosak.
Tapi usually one card kan dia akan ambil banyak input. Tapi untuk assume untuk buat rosak sekali. So how does sebut rosak sekali?
Should be yeah.
You have to explain it in the failure consequences, because question like him, you will trigger a lot of questions. Might as well that in your consequences you have to return the final, the details. This will only happen when
Tapi kita ambil yang paling risk, yang paling teruk lah.
yang paling teruk lah, but you have to put a little bit of details lah.
Take the highest right, highest rating right. So double jeopardy. Maknanya bukan sekali jadi terus.
What they think is that they have voting.
Voting ni sistem apa?
Thank you.
Any more questions? Okay. All right. Next, our final group here. Rotating. Rotating. Rotating, rotating.
Cepat, tak soalan, Pak. Tak ada soalan.
Rotating.
Okay, so similarly we have like two components, centrifugal
One discussion.
and seal system. Okay, so function of the centrifugal pump is of course to transfer liquid. So the failure mode that we can detect is high vibration. So the possible cause leading to this is first, cavitation. Number two, impeller plate damage, FOD. Third is misalignment. Next is bearing damage or oil leak. So the causes for this, okay, they are linked, okay. So for cavitation, the cause for this is operating error. We are operating at outside our safe operating pressure. And then for impeller plate damage is maintenance error. Let's say maybe the inlet has strainers, right? So maybe for some reason the strainer was not there.
Question? Yeah.
The debris managed to came into the impeller.
Okay, focus.
Okay, so for misalignment is also maintenance error, and for bearing damage is operational error, and for oil leak is installation error. Interesting. Okay, so failure effect A. What is this? Medium cannot sufficiently supply to the processing plant, so this will trigger the LL alarm on our downstream equipment. Okay. So B, pump seal failure rate increase leading to asset damage.
Okay.
And C, oil leak lead to environment and integrity issues. Okay, so for consequences, we have asset damage, environmental safety leading to production loss, and also non-compliance to statutory law. Okay, for mitigating actions, first we have review vibration monitoring schedule of frequency, and secondly enforcement or to revise our PM implementation. So the frequency we actually didn't take any assumption, so it depends on our failure rate and TPF.
You should have one common one, right? Vibration monitoring.
Yeah.
Yeah.
Okay, moving on. No questions.
Okay,
right?
question.
No questions.
Question.
Does vibration monitoring does not fall under PM implementation? Right.
Vibration monitoring does not fall under PM implementation.
So usually the job list, right? Job list of the PM usually have vibration monitoring.
Where's your work center?
Work center maintenance. Unless electrical want to take up this one.
Yeah, work center tak ada. Okay. Question.
Dekat you punya mitigation number 2, enforcement of revise of PM
implementation.
So yang tu
interval lah.
Macam tu, macam mana you nak masukkan dalam task list and recipe and so on?
Desmond, can you bit?
Okay.
Ada interval tu macam mana you nak letak?
Interval macam mana soalan macam ni?
Mitigation ni dah assume that we have the plan already.
Ulang balik. Satu you boleh buat vibration monitoring. Itu kita akan letaklah contohnya tertaki mati atau proses mati for mechanical maintenance. Tapi nombor 2, on this activity, enforcement revise of PM implementation. Yang tu you nak assign ke siapa and what is the interval for the activity and how you nak masukkan dalam SMP lah.
PM okey lah. Kalau macam PM memang selalunya dia kena, kalau nak revise tu kena bawa ke TTT semua kan, sebab nak tambah job list, sebab nak tukar interval lagi,
kena develop ERS baru lah kan.
Ya betul. Mesti kena ada
existing PM yang MSR, Maintenance Strategy Review.
Tinggal.
Tu memang ada interval kan.
So should it be put here or somewhere else?
I don't think so.
Nanti boleh ini boleh apa ni, akan boleh raise ke PPM punya ni people untuk tambah sebab MO kan, nanti kan untuk PM boleh keluar MO kan, lepas tu akan keluar job list. Rasanya selagi tak keluar MO, selagi tu boleh tukar apa yang ada kat dalam job list, tapi kena justified lah, I guess. Justified and reviewed by BTA.
So in my head, we're doing FMEA. FMEA is like a method for ARS. So in ARS, we do like maintenance, operation and stuff like that lah. So things like review, we do in MSR, right? So do we put that inside ARS also? Do we put like the actions of mitigation, I don't know, improvement actions, recommended actions in ASR or MSR in ERS also?
Okay, first questions. Your FMEA, should you write your frequency or not?
Yes.
So should you put something like depends on failure frequency? You must have something.
I think must have a specific value.
Yes, you must have a specific value, right? You must have a specific, because, okay, like this. Review vibration monitoring. The more frequent you do your vibration monitoring, it will give some impact to your high vibration or not. The more I do hari-hari I buat, my vibration can improve or not? No, right? So there must be a time-based things that you have to monitor. It's not like you monitor on and off condition ke tidak. You must have a time base to monitor it. A time base is not depends on failure frequency. The time that you fail is already too late. Due to high vibration, it's already too late. So you must have a time base to monitor your vibration. So it could be something like a 3 month, 2 monthly, 3 monthly things, right?
Means you need to be more specific.
You have to be specific in your FMEA.
So
right.
One cannot do review vibration management.
Okay, the second one, enforcement, revise or PPM. This one is recommendation. So when you come to the task list, it won't be like that lah. It couldn't be like that, right? This one is only like monitoring your vibration lah, for a time-based 3 monthly, 2 monthly. To answer, I think Sheila questions, whether or not in your MSR you want to review this. Inside your EDA, first thing first, you need to download your existing task list, correct? Then you have to review your existing task list, still valid or not?
Yes.
You valid, you pakai balik lah. Kalau not valid, then you tukar new. Ataupun your task list is still correct, but your frequency not correct anymore. This is your MSR lah. Question? High vibration question? Next, high vibration question?
Okay, moving on next. The next component will be our seal system. So the function is to contain medium from the environment. So the failure mode will be mechanical seal leak. So the cause leading to this, the mechanism first is incorrect assembly of the mechanical seal. B is the viscosity of loop oil higher than the spec. And C is wear and tear. So the causes for this is first maintenance error, installation error, and also what is this handle? Management planning error. Yeah. And for the effect, first is leakage due to incorrect assembly leading to high vibration, due to bearing is not sufficiently lubricated. The consequence for this is first asset damage and environmental safety. So the mitigating actions that, especially I think this one should be corrected lah. First, what we wrote is to conduct a refresher training for our staff and also new checklist for the seal assembly. So probably that should be revised further. Yeah.
What to do with the seal? When you want to plug something tightly to your seal, what you need to do? What are the things to protect your seal system?
You like the wear and tear, right? So it's not to fail.
Flushing.
Flushing, yes. Yes, your seal flushing plan, yes. Yes. How frequent you need to do that? How to check? Yeah, it could be one of them, your task list. How to protect? Your wear and tear is when it fail, you just tukar lah kan? I think this is what he trying to say lah. Seal, seal system. But for this one you can monitor. How to monitor your seal system usually? Huh? Leaking rate? But the leak already. Before it leak, how to monitor it?
Pakai Snoopy test. Snoopy.
Oh, this is leak, right? Leak test. Yeah.
Can check using the temperature as well.
Kan? To protect your seal, check temperature. The thing masuk is okay or not? How to check kan? Pressure masuk.
Drain boleh.
Draining.
Mechanical seal ada drain kan.
Ada?
So buka drain plug tu.
Then check.
Check for debris ke apa.
Yes.
For sampling.
How frequent you need to check the drain? Then you have to put it here if this is required.
So kita sama macam ni, oil analysis. Apa? Oil analysis.
Sampling.
Depends on medium kan. Medium of water, of pump tu. So kalau dia hot water, kalau dia crude oil.
Yep. Crude oil cannot lah kan? Drain. But your task lead you cannot put like to conduct refresher lah. This is a recommendation, but you want to put into a task itself, which is come out as a work order. When you look at your work order, you auto say that.
To conduct refresher.
I think refresher training can also be applicable to operating.
But it will be a recommendation. It will be a recommendation, but it's a task list. It might not applicable. Yeah. RCA yes.
Okay, good.
No more. No more. Yes. Your friend want to ask.
For failure effect, how specific do you want to be, or how specific should you be? Because usually, if like most of it is like plant trip, not plant trip, equipment trip.
Yep.
Equipment cannot do this, but
Yes.
very detailed.
Yes.
So
Correct.
How detailed should you be actually?
I think it should be as detailed as possible.
If you want to do in detail, please do like this. But usually people just put pump trip. Pump trip. Yeah, pump trip. Because it's immediate.
If it's like this, then I'll have like tons of components. Then I'll
Correct. Exactly. This is only two conditions. That's why they can do like this. When they have a lot, then they will tend to keywords. All right. Okay. All right. Thank you all. So, all right. So it's already 5 o'clock. You guys okay with the FMEA? This needs a lot of practice lah. Okay, a lot of practice, especially that.